Hi, I'm Jocks, and welcome to Layman's Guide to Cracking the Coding Interview. Just earlier, we talked of fundamental basics of quick sort. So now we're going to be doing another important sorting algorithm, and it's a merge sort. So merge sort works on the basic principle of divide and conquer rule. First, we divide the array, and then we have a bunch of partisans. Then once we have a small partisans, we do the sorting, and then we merge that. Let's get into the examples here. So in this case, this is a given array, and it's unsorted, and it's random. So now what we're going to do is we go to the midpoint, and then we partition. So now we have a left hand side, and then we have a right hand side. And again, on the left and the right, we go to the center, we partition that. Then we have two items in each partitions. So once we have a two, then we can compare each other. Based on the comparison, we do the sorting. So once we have 7 and 3 here, we can do the sorting here. It's just a swapping, just by comparing the first index and the second index. So in this case, 7 is greater than 3. So 3 comes earlier and the 7 comes later. So goes for the second partition, third partitions, and the fourth partitions. We do the sorting, and we have a 2, 16. We have a 4 and 24. And then 9 and 11 remains the same because 9 is smaller than 11. So once we have all the partitions, we do the merge. So earlier we had a divide, now we do the conquer. So we need to merge all the partitions here. So we have one partitions, another partitions here. So now we try to merge. So when we merge, we look into the first index of first partitions and the first index of the second partitions, and whichever is the smaller, we put the smaller value on the first index, and then we compare this with the 16. And here 3 is smaller than 16, so we put 3, and rest of the remaining would be the 7 and 16. So when we compare, 7 is smaller, so we put onto the third index, and then 16 is the last one, so we don't have to compare anything with any other elements, so we just put it 16 at the end. So goes for the another partition here, and in the end we do the same comparison, then we have the merge sort. So this is the merge, and it's been sorted. So earlier we have a 7, 3, 2, 16, 24, 4, 12, and 9. Now we have a 2, 3, 4, 7, 9, 11, 16, 24 in an ascending order, and it's been sorted. So let me write a program, and I'll run the program, and let's see how we can do this. Let me open this notepad so I can do. So in this case, we need to create the two functions, because first we need to do the partition, that is just call a merge sort, and another would be merging the two partitions. So let me start this. So I create a function called merge sort, and I pass the array or the list in Python, and I'll have I and the index L and the index last. So we do the base case as always. If array is empty, simply we return false. Then the second base case. Second base case is when we have two elements in the array. In every partition, we may come up with the two elements. We do the comparison, then we do the swapping based on the smaller and the bigger quantity. So this is our base case. Say that we have a length of an array is 2, because we'll be using the recursive function. So whenever we hit to the two elements, we do the comparison, and then based on that we do the swapping. So if the first element is greater than the second element, right? Okay, so in this case we do the swapping. I don't want to create another function, so I just wanted to do it right here. And then we give the temp for this. I think I did the swapping. Yeah, I think so. So if the index first is smaller than index 1, then we don't have to do anything. We just simply return the given partition. Return, sorry, it's not going to be partition, it's just going to be array, because this will be the small partition. So I'll just put the array here. So we check the condition when we have a two integers in the array. So I think that is, and if we don't have a 2, if it's a more than that, then we do the dividing, right? So in this case we have to divide from the center, so I take the midpoint. So midpoint would be the min. Sorry, I don't have a min here. I have to use the I plus and length of the array, because length of the array keeps changing every time when you do the partition. And length of the array and minus I. So I will do this so that I get the integers, not the floating value. If I just have one divide, then it's going to be the floating point value. So we don't want to have the floating value because we are dealing with the index. In this case, we simply return the partition of that. So we call the merge search, and we now gonna have a half from initial to midpoint and from midpoint to endpoint. So let me partition this array. Let me put it like from I to mid, right? So we're gonna have a half of it, and then we're gonna start from I, then we go just up to the mid, and another partition would be the merge search, and I'll have a rest of the element that is from mid to L, and then oops, and then from I to mid plus 1, I guess. Okay, let's just put it like this. If I get some error, then I'm just gonna fix it later. And then we have a two partitions, and when we hit to the endpoint, then we do the merge. Oops. My keyboard is not working. Let me just paste whatever I copy, and I create another function called merge. All right, I'll just create another function called merge. So let me just go through again. So we have an array, and we have an initial as a 0 and the length of the array. So if array is completely blank, which may even happen, in that case we just return false. And if we have the array of 2, then in that case, okay, I give a more spacing, and this shouldn't be an extra space earlier. So when it's 2, we compare the first element with the second element, right? And if it is, then we swap, else we just return that. Oh, I think I forgot one of the conditions. What if we have a odd numbers of items in the array? In that case, the length of the array could be just 1, right? So if it's 1, oops, I keep on hitting more space. If it's 1, then simply return the array. We do nothing because we don't have to do anything, and when we just have 1, return. All right, I think this is okay. All right, now we need to implement the function called merge. So let me create the function called merge. So in the merge, we have the two array, right? Always like one on the, let me see here, one on the left hand side, one on the right hand side. We do the comparison, we do the merging. Okay, I think that would do. So let's say I have an array 1 and array 2. So we need to merge this by comparing every element. So I compare if, okay, let's do the base case first. Our base case should be if I, let's say if I is none in this case, or array 2 is none. So if we have a none, we don't have to do anything, right? Sorry, if it is not none, then we need to do the merge. So that's why let's create a new whole placeholder to put those values. So let me say new array, which is blank, and let me have I and the j as an index. Let me just put the 0, 0 for both. I might have to change this later, I'm not sure. So while I is, let's compare the length, because we need to compare the length of the partisans. Array 1, if the length of the array 1 is greater than I, and I'm typing something wrong and silly here, and because we first need to check if I and j's are smaller than the two partisans, that should be array 2. So we check, we perform this while iteration on if and only if I is, sorry, if length of the array is bigger than I, because I and j is 0 for now. So in that case we perform that. So while in that case, if I keep on need to checking the pictures. All right, okay, I think I got that. So oh, I think merging is more complicated than the partitioning. Okay, if array I, so we need to compare the value, right? Because we are starting from I, so we need to compare the element partition 1 and the partition 2. So okay, which should be j over here. So we're comparing the first element of array 1 and the first element of array 2. If the first element of array 1 is greater, in that case we are doing the swapping. If 2 is smaller than 3, put 2 on the new array and the 3 onto the second value, right? Okay, I think we are on the right track. I may encounter the error. So in that case, just put the new array. I can just append that because it's a list. So when I1 is smaller, then I just append the I2 first, right? And then I increment the value of j, because I put the value of j there, so then I need to increment that. I am sure it's okay. So hold on. All right, so I compare the first, and then if I2 is smaller, then we open in the new array, and okay, still we need to check if how big is the j. We don't know for sure. It might be a 2 or 3 or 4. So again we check if I2 is bigger, length of the array 2. So if I is greater or equal to the length of the second array, in that case we can still increment the we still have I as a 0, so we need to increment. So let me put while I is still less than length of the array 1, because I represents the first array. In that case we simply append this. array1 is I. Okay, I have that track. It's kind of hard to keep track of that. And then we simply increment the j, sorry, increment the I. All right, that's it, I guess. So we compare if array1 I is greater than the array2 j, and else if it's not greater, right? If that's not the case, then we simply need to put first array, and the integer would be, sorry, the index would be the I. Array1 is I, array2 is j. Okay, we have a good track now. So in that case, again, we increment the I. We increment by 1. Same goes here if the I is greater, because we don't know how big is the I, so we check the length up to here, right? Yeah, if that's the case, then whatever we did in earlier, we just compare while j is less than the length of the array 2. J is always 2. Okay, I note that, and then I add that new array that happened. Then I just put the second array right here, and then we increment the j as well after that, because I think this is making sense. If we go here, in this case, first we compare 2 and 3. 2 is smaller, we append it into the new array, and then we compare, we increment the j and it goes to the 16. Then we compare here, and 3 is smaller, we put it here, and then we increment the I as well, and then we have a second element and we do the comparison. That's why we have a while statement there at the first, and in that case we put it here. On the big partition we do the same thing. All right, I think we are on the right track. If not, we have to redo this again. I hope we are on the right track, and that's it. I think that's it. We just return with the while loop. Okay, so in this case we just return the new array, because this is the merged and these are the two partitions. So we have a two partitions, we do the comparison. Let me see if I'm on the right track. If length, okay, there's no issue on here, so we do the first comparison, and if so, if I is array1 is smaller, then we append there, then we increment, and then we check if the j is bigger or equal to length of this, right? Yeah, I think so. And in that case we still need to compare the I, because the I is always on the left hand side. Okay, it's a little bit confusing. I think it should be okay by now. Okay, let me just take one like an example, and then I'll try to run on my IDE. Let's take some random 9 7 4 15 6 2 8 3 1. That's it. How many? 1 2 3 4 5 6 7 8. All right, we have a even thing, and this would be half of that at first. Let me just copy. Rather, I should do it in the ID and then I do the debug. That should be fine. All right, so I'll just copy this into my ID, and let's just say that I have a given value as this above, so it's going to be easier for me to put it in the IDE. And I just need to print print Morsat, and it should be the partition. First the partition is the entire, and we break from here to the length of the given. Okay, this video is getting a little longer today. All right, I'll just copy everything except the first line. All right, I copied that. So now I'm just gonna paste it in my IDE and then I'm gonna run. Okay, here we go. So now I have it here. Okay, I just put the breakpoint so that we can debug, and I put the same value, and let's just run fast. All right, I think it's okay. We need to check for other examples as well, but for this example it's fine. But I wanted to do the debugging so that we could see how it's been done at partitions. So I have the debug breakpoint over here. So let's do the debugging. So checking the base case, not true, not true, not true over here. So we have a midpoint, and the midpoint is 4, and we have a total of 0 to 9. So 0, 1, 2, 3, 4. So we have a 1 partition and another partition here. So let's go up to here. So let's go up to like a 2 so that we could get it more precise of the merge. I'm more confused with the merge. So okay, we'll have a 2, then it's gonna do the swapping. Okay, so we have 7 and 9. All right, so let me go to the merge. Let me put the debug point here as well. Okay, here am I. So 7 and 9 and 4 and 15. 7, 9, 4, 15. First do the comparison. 4 is smaller. Put this into the new array. Here we go. Oh, I need to run one more. Here we go. We put it here. And then we are checking if j is bigger than the length of the array, which is in this case. And then we okay, in this case this is bigger, 7 is bigger, sorry, 15 is bigger than 7. That's why we are appending the 7 onto the new. All right, and then we check the conditions again, and I has been incremented, j has been incremented. So from 0 to 1, this is perfect example. And here 9 is smaller than 15, so it goes to the if else statement. Then we just put the 9 here. Then now we only left with 15. We increment the I as well, which will not be executed because our while loop will be terminated. So finally we have a j as well, sorry, the 15 as well, and we'll just return. Okay, so we'll just return 4, 7, 9, 15. I think there's no issues with this, so I don't have to debug all the partitions. I'll simply run again. There we go. Perfect. I think it's quite a long video today, but thanks for bearing. Thank you.